All right, okay. So again, today we are going to talk about transformations of functions. And when we started this, I told you we have multiple types. We have translations, we have rotation, we have reflection, we have stretch, etc., etc. Okay. So let's talk about what we have already discussed. Translation was the first type. And we know that whenever we add or subtract something in the entire function, for example, this positive 3 or this negative 2 was added to the entire function. This used to be a translation in the y-axis. And if I was adding positive 3 in the translation vector, I was writing positive 3. So things were the way they look like. I added positive 3 here and I had positive 3 here. Okay, then when I will subtract 2 from here, in this case, the translation vector would have been 0 and -2. So this was when I was adding and subtracting something in the entire function, and how it looks like on the graph. Blue graph was basically the graph of the original function, the blue one. When I will add positive 3, this blue graph would shift 3 units above. And when I will do negative 2, this graph would shift 2 units down. So it's exactly what it looks like. Any confusion so far? Anything that you were not able to understand over the weekend?
No,
Yes.
Miss Edith.
Okay. All right. Okay. So this was about the y-axis. Then I just, wrote some key points which would help you in answering the past paper questions directly. Since we have not done all the transformations, that is why I did not start the past paper questions, but you will see that this thing exactly would be used to, get good 3 marks. So we know that whenever we were adding positive a to an equation, the I'll just read the definition. The graph of y equals f of x plus a is a translation of the graph of y equals f of x by the vector 0a. That's simple, right? If I was adding a, the translation vectors used to be 0a. If I had minus a, this would have been minus a as well, right? This would have been minus a if I had a minus here, but since it was plus, so it would be plus. Okay. Then we know that this was a quick discussion about the translation vectors. This was for the x coordinate, this was for the y coordinate, and then we discussed how things are for x. Initially, we were just adding and subtracting something in y. This time around, I'm subtracting in x, and some of you felt like the graph would shift to left. Okay, so the original graph was basically this red one, and when I did -3, I did not get the yellow graph. I got the blue graph. It's opposite. Whenever I would be subtracting something with x, my graph would shift towards the right. Okay, so this negative was basically for right and positive would basically be for left. It's other way around, unfortunately. Okay, so the red graph shifted 3 units to the right side, and then when I added positive 3, so for this positive 3, the red graph shifted 3 units to the left. So for positive, it's left. Okay, it's opposite. All right, okay. Then again, we had this key point, and now things would make sense. The graph of y equals f of x minus a. Now we did not add subtract anything over here. We have subtracted something with x directly. And this is going to be a translation of this graph. And the translation vector would be this. So we had a minus sign here. And here we have positive a. However, when we were doing -2, when we had a -2 here, we had -2 here. Okay, since when we do something with x, the change feels genuine. When I will add 2, it would move 2 units above. When I will subtract 2, it would move 2 units down. So this impact would be seen on the translation vector as well. But if I talk about x, things are other way around. Okay, when you are subtracting something, you would actually be writing down positive version of that. When you are adding something, you would writing down the negative version of it. Okay. All right. Okay. Then we discussed some questions. I think that part was good. Anything else that you guys need to ask? I'll just stay on these questions. Anything that's coming to your mind?
No, Miss.
All right. Okay. Then we have the next type of transformation, and that is reflection. This is the 6th unit of the chapter. All right. It's 2.6. Reflections. Okay, again we need to understand what change in graph would reflect your graph. Reflection makes sense. We know it would be reflected either by the y-axis, like either the line of reflection would be y-axis or it would be x-axis, but we need to see when exactly would this be happening. Okay, this is what we need to consider. Okay, all right, let's talk about example number 1, and this, by the way, is type 2. We are done with type 1. This is type 2. You'll see what change in the equation would make you feel that it was a reflection. For example, we had y equals x squared minus 2x plus 1. And now we have a transformed version of this original equation. And that is going to be y equals minus x squared minus 2x plus 1. So this is equation 1. Let me just write it down with blue again. This is equation 1. This is equation 2. Okay, so far you can just see I've just added this negative sign and nothing else has happened. Let's see what would this do on graph. Okay, that is what we need to understand. All right, so let me quickly make the 2x's. This is x, this is y. For the blue one, the graph is going to be something of this type. I'm just making a shape, and for now, just trust my words. And if you guys are interested in making this, you know now, we need to factorize this. Once we have the factorized version, we will get the x-intercepts. You can plug in x equals 0 to find the y-intercept, and then you will make this graph. But this would get better once we talk about this stuff. For now, just trust me. The graph of the first equation is this blue one. The graph of blue equation is basically the blue line I've made, the blue curve I've made. Okay. Now, we have added a negative sign, and because of this negative sign, now I'll make the graph of the second equation, or the red one. It is going to be something of this type. Now, the blue graph and the red graph are not that appropriate according to the equation. Forget about that. That is not what we are learning. Okay. Like this is going to be 1. It looks like it was on 2, and otherwise it's okay. All you need to understand is that what would be the relationship in the blue and the red graph considering this minus sign. Okay. So now you need to know, whenever we have negative version of the entire equation, for example, this is y equals this, and this is negative y, right? This is basically negative y. We have minus and whatever we had initially. So this minus is basically coming with the entire thing. Just like when we were adding 3, when we were subtracting 2 in the entire thing, the change was being made in the y-axis, in the y coordinate. Similarly, this minus sign is not coming with x. This is coming with the entire thing. So because of this, the rule says that the red graph would basically be made as a reflection of blue. Okay, let me just write down the note and then you would understand the idea. Okay. Key point is the graph of y equals minus f of x is a reflection of the graph y equals f of x in the x-axis. Okay. The graph of y equals minus f of x. This is what exactly we have discussed, is a reflection of the graph y equals f of x in the x-axis. Okay. So this has happened in our case as well. How would things, let's relate to things now. Okay. All right. So this is basically your f of x. It's y equals f of x. This is y equals minus f of x. If we talk about their graphs, the red graph would basically be the reflection of the blue one in the x-axis. So you can see things are different. When we have a minus sign with the entire thing, it is a reflection in the x-axis. And now when I will add the minus sign with x, it would be a reflection in the y-axis. Okay. So this is how it is. Anything that you would like to ask at this point? Yes, Munja and Rafe?
Yes. Best if it was just negative x square and everything was same, like negative 2x plus 1, then the
In that, yes,
reflection will,
yes. Say it again.
so at that point it will be just a curve with the side face, but
Yeah.
above the x-axis, right?
Very good. Yes, well done. Very well said. Excellent. That would just make a difference in the nature of curve. Like it would be, if it would be negative, then in that case it would be a maxima curve. You would be having a maximum point. Since it was with positive x squared, so we had a minimum point, right? If you would only have a negative with x squared, you're right. But this negative is with the entire thing. Okay, so when it's with the entire thing, it would just be a reflection of what we had originally about the x-axis.
Okay.
All right, perfect. Okay, let's talk about the, yes.
What about, I mean, the positive one, you said that it is for the entire equation. What about if you have another,
Sorry, say it again. Say it again.
2 steps down? Instead of having a 1, you said minus, then bracket x squared minus 2x plus 1. Let's say we have another constant which is not 1, but it's a different constant like 2 or 3. How does it mean that, I mean...
So like you're saying, we would have this minus sign, and instead of this 1, I would have some other constant, right?
Yeah, like minus 2. Then
Minus
bracket.
2. Let me
Do
write
we
it
have
down.
such a situation like that?
Yes, definitely. I'll tell you. Minus x squared minus 2x and then minus 2. This thing?
No. In
Then?
front of the bracket, where it says minus, let's say we put another constant there, which is minus 2.
Oh, this.
Yeah. Do we
Okay,
have a
okay, okay.
situation like that, or
All right.
no?
Okay, oh, I guess no, not really, but you will see the change that the graph would have once we are adding 2. You can have that certainly, and this would basically be discussed in stretch. Okay, we'll talk about it in stretch. This would basically make an impact on squeezing or stretching the graph. So by adding or subtracting a number, the graph was shifting. By a minus sign, it is reflecting. And now when we will multiply a number, it would basically stretch or squeeze the graph. But we'll come to that once we are done with the second type. Okay.
Okay, thank you.
All right. Okay, very good. All right. Okay. But overall, just to answer a question, that would be a reflection. But the only difference would be that it would be, it would be more stretched, like it would be a big graph rather than the red one. Okay. But we'll come to that once we talk about stretch. Okay. Another thing that we're going to talk in the second type is basically how things would be when we would be adding minus with x. Okay. Example number 2. Now imagine we have y equals x squared minus 2x plus 1. This is equation 1. And for equation 2, I have y equals minus x squared minus 2 into minus x plus 1. That's equation 2. Now here I've clearly, or the example clearly had this minus sign, okay? It could have been this way as well, that the examiner would just give you this equation y equals x squared plus 2x plus 1. Now you guys need to think about it this way as well, that this plus basically means we had minus x, and minus x squared would again give you x squared, right? So it's not necessary that the examiner would give you the equation in this type. He can certainly give you this equation as well. And the third equation that I've written is basically after just simplifying the second one. So you guys need to be good at this thing yourselves, okay? All right. Anyways, for now, once we'll talk about past paper questions, then this idea would get clear. For now, this is the scenario, and let's see how things would be for this one. Let me just make the graph for both the things. X-axis, y-axis. What has happened? I've added a negative sign and all the x I had in the equation. Means now my graph would reflect in y-axis. Okay, so let me make the original graph. It is going to be something of this type. This is for equation number 1. Now I need to reflect this thing in the y-axis, and then I will make the blue graph. This is what it is going to be approximately. Okay, it's just a rough idea about it. So this is what happens. What was the transformation in the equation? The transformation in the equation was that we just added a negative sign with x, and because of that negative sign, we are going to reflect the yellow graph or the graph of the original equation in the y-axis. So you can feel the change. When we have negative with x, the line of reflection would be y-axis. Over here, you guys would have to keep a few things in your mind, because things are other way around. Students at times say that when we're adding x, y, isn't it the x-axis? But once you will plug in the points, you yourself would see it would reflect in the y-axis basically. So let me write down the note for this one. Okay, it says it is the next key point. The graph of y equals f of minus x is a, 1 second. Reflection of the graph y equals f of x in the y-axis. Okay, all right. Now please pay attention. Okay, Ahmed, you have just joined, so please try understanding this idea, and this would be a quick recap for all of you. So far, we have discussed the second type of transformation, that is called reflection. Now, reflection makes sense. We have a line of reflection and the graph is reflected, okay? Here, the two lines of reflections could be the x-axis or the y-axis. We just have two scenarios. Scenario one says when you would be adding a negative sign with the entire equation. For example, equation number 1 was x squared minus 2x plus 1, and equation number 2 is minus x squared minus 2x plus 1. So this minus basically means that you have added a negative sign with the entire equation. So the blue graph would reflect by the x-axis, right? X-axis is basically the line of reflection, and y, just read this key point. The graph of y equals minus f of x is a reflection of the graph y equals f of x in the x-axis. So when you are adding negative to the entire function, your graph would basically reflect about the x-axis. It would be a reflection in the x-axis, okay? This is something that you need to memorize. Case 2. In case 2, we had a negative sign with x. In the previous case, the negative sign was there with the entire equation. This time around, it's just with x. So it's negative x. It's negative x. So whenever you would be having negative x, difference would be that the graph would reflect in the y-axis. The yellow curve is basically for the first one, for the original equation, that was y equals f of x. The second equation is basically y equals f of minus x. So whenever you would have f of minus x, it would basically be a reflection in the y-axis. So I just made the yellow graph, and considering this minus with x, I made the blue graph by reflecting it in the y-axis, okay? And here was your key point. The graph of y equals f of minus x is a reflection of the graph y equals f of x in the y-axis. All you need to understand is this minus with x would basically cause a reflection in y-axis, and this minus with f would basically cause a reflection with the x-axis. It's other way around, okay? So by now we have discussed two transformations. When we were adding and subtracting in the entire function, the graph used to shift 3 units up or 2 units down. And whenever we were adding and subtracting with x, it used to shift right or left, and things were opposite for x. When we were subtracting 3, it looked like it would go to the left side, but no, the red graph x3 shifted to the blue one, right? For minus, students think that it would go to the left, but for minus, it's actually shifting towards the right side. And for positive, it's basically left. So the yellow graph is basically made on the left side of the red one, okay? This was an idea about translation. And then we had a few key points. Then we discussed some questions in the previous class. And today we have discussed reflections. That was the second type. And we know we have two cases, and the two cases are done. Anything that's coming to your mind, please tell me quickly before we talk about the past paper questions. Not the past paper questions, some example questions, sorry. Yes, students, please quickly tell me. We just have one more question and that is it for today. Anything that's coming to your mind?
Is there like any logic behind the second key point?
The second, like this one? The
Can
one?
we like...
Mhm.
Yes, miss. The second
Okay,
one.
I'll tell you. It says the graph of y equals f of minus x is a reflection of the graph of y equals f of x, okay? In order to understand this, it's x squared minus 2x plus 1, okay? It is y equals x squared plus 2x, one second, x squared minus 2x minus 1. This is basically my graph. Okay, let me just go and check again. Yes, okay. And let me just consider a point. Let's say I can take x equals 1. So this would give me 1 minus 2 plus 1. Oh no, this would not work because it's 0. So negative would not make a difference. Let's use 2 or maybe 3. 3 squared minus 2 into 3 plus 1. This would give me 9 minus 6 plus 1. This would give me 4. Okay. So this point is 4. This means the coordinate would be 3, comma 4. Let's go and see where is 3, comma 4. 3, comma 4. So 3 is going to be somewhere, let's say it would be, 1 second. It would be somewhere here, and let's say this is 4 and this point is 3. So this is going to be, maybe this one is 3. This is going to be 3, 4. Okay. This point came from the first equation. Okay. Let's talk about the second equation or the transformed equation. That was y equals f of minus x. So for this, it would become minus x squared minus 2 into minus x plus 1. And this would give me x squared plus 2x plus 1. Again, let's consider 3 as the point. 3 squared plus 2 into 3 plus 1. And this is going to give me 9 plus 6 plus 1. And this is 16. So we had negative 3. This was basically negative 3. Let me write it down this way because you guys would again think I added 3. Negative 3 squared minus 2 into negative 3 plus 1, 9 plus 6 plus 1, and this would give me 16. So the x coordinate was negative 3 and this thing was 16. Okay. Let me just scroll up and see. One second. Minus 2, and now I'll add minus 3 plus 1. Okay, because this would actually mean negative 3. And this is going to be 9, negative 6 plus 1. So again, this would give me 4. Okay, I'll tell you what I did wrong initially. This is what the modified equation would look like. Okay, now I need to add negative 3 as x. So this would be negative 3. This would be negative 3. And after simplifying again, I'm getting 4. So this would not be minus 316. This would be minus 3 and 4. And now you guys can directly see this as basically 2 points of reflection. This was 3 and this is going to be negative 3 and 4. So that is why it's reflection. Okay. What exactly have I done? I just had the modified equation where I had negative with all the x. I added another coordinate that was minus 3 and I got it as the exact reflection. Okay. This is basically the difference.
Okay, miss.
All right. Okay. Very good. Okay. Let's talk about proper question. Okay. It says, it's question number 1 for the second type, and we only have one question. The quadratic graph y equals f of x has a minimum point at 5 minus 7. So the quadratic graph y equals f of x has a minimum point at 5 minus 7. Find the coordinates of the vertex and state whether it is minimum or maximum for the following. Okay. Part A says y equals minus f of x. Let's discuss this. Acha. The quadratic graph y equals f of x has a minimum point at 5 minus 7. They did not give you the original equation of the graph. All you know is it has a minimum point. Let's just think about the scenario. So it is going to be a curve with minimum point and the coordinates are 5 minus 7. So the x coordinate is 5 and the y coordinate is minus 7 and it has a minimum point. So this would basically be the point, and I'm just going to make a rough sketch of the graph. So it would be of something of this type, right? Since it has a minimum point, so obviously I've just made the minimum point and I just made a rough sketch out of what was given. Find the coordinates of the following vertex. Again, what is vertex? Vertex is basically the turning point, or it's the minimum or maximum point of your quadratic curve, and state whether it is minimum or maximum. Now, when we have minus, when you do minus f of x, how do things change? When we are multiplying minus with the entire thing, we know that x-axis becomes the line of reflection. Now I am going to reflect this in x-axis. So if it was 5 and minus 7, it would become 5 and positive 7. And this is going to be the point. And this would be the graph. So again, we can see it is 5 and positive 7 and it is a maximum point. So if I talk about the solution, I'll write it down this way. The vertex or the turning point is 5, 7 and it is maximum point. Okay. Any confusions with this? The blue graph was basically the original one for y equals f of x. All I could see was that I added a negative sign with the entire thing, and that means it would be reflection in x-axis. I made the red graph, and now I was only supposed to determine what would be the coordinates of the vertex of the modified or the transformed graph, and I had to state if it would be minimum point or maximum point. Okay, so this is what I've done. Anything that you would like to ask at this point?
No, miss, everything's clear.
Okay, perfect. The next part is for you guys. Please do it. Imagine if the transformed equation was y equals f of minus x. Okay, now this minus implies line of reflection would be y-axis. This red graph would basically be reflected in the y-axis. Now think about it. The blue graph, basically, the blue was the original one. This is for y equals f of x. Yes, say it again.
Miss, minus 5 and minus 7 and it's minimum.
Very well done, excellent. Okay, so the blue graph is the original one. This minus is telling me that I need to reflect it in the y-axis. Why in the y-axis? Because this time around the minus sign is with x, okay? I'll just make a rough sketch. A very, very rough sketch, because the sketch is not required. I'm just making it for my convenience. And you can make it by all means, okay? And now I can see it again, where it would be reflected by the y-axis. It would again be a minimum curve with the minimum point, but the coordinates are different. It's -5 now. It would be -5 and -7. So the vertex is -5, -7, and it is a minimum point. Okay, this is how we need to understand things. Now tell me, Ahmed, Munja, and Rafe, if you have any questions, anything that you need to ask, feel free to ask me.
Is everything clear?
Okay, Munja, anything that's coming to your mind? Any other scenario?
No, thank you, ma'am.
Okay, and Ahmed, what about you? Do you want me to revise something again? Please feel free to tell me. Yes?
I think I understood.
Acha, okay. Were you able to understand translations?
Translations?
जहाँ पे we shifted the graph, like the first one जो हमने we discussed this on Thursday. This thing, when we were adding or subtracting something in x.
Yes, I
or
understood this.
okay, so this was just shifting. This was about shifting. So translation was just, you can think about it as if it was shifting. This was type 1. We were adding and subtracting something in x or the function. Reflection is reflecting. We know what exactly reflection is, and how would we know if it would be reflection or not? It would be because of this negative sign. Okay, so if you have a negative sign with the entire function, or with x only, it would be reflection. If we would be having a negative sign with the entire function, the line of reflection would be x-axis. The graph of y equals minus f of x is a reflection of the graph y equals f of x in the x-axis. We just added this negative sign. We multiplied this negative sign with the function, and it was a reflection in the x-axis. The blue graph is basically for this one, for the original one. And after adding this negative sign, I got this curve. So it was basically a reflection in the x-axis. Okay. Type 2 and case 2 was basically this, that now I added minus with x only here. So how would things change? For this scenario, when I would add negative with x, it would be reflection in the line of y-axis. Okay, so the blue one was the original one, and when I added negative with x, I got this one. So it was reflection in y-axis. And then the question that we have just discussed was basically this, that we had a minimum curve, the blue one, and the point was 5 minus 7. How would things change if I had this one? What was here? I had minus f of x. From minus f of x, my line of reflection would be x-axis. I made the red graph. And after making the red graph, I can see it is a maximum point, and the coordinates of the maximum point are 5, 7. And for the second scenario, I had a negative sign with x only. I know that when I would have a negative sign with x only, it would be reflection about the y-axis. So I just made this yellow graph using the blue one, and again it would be a minimum point, and the coordinates would be -5 and -7. Right, Ahmed?
Okay, I understand.
Okay, and still I'll share the recordings. Since you joined late, you can watch the recordings, and things would make more sense. All right, so I'll stop the